Good afternoon. Welcome to our Arduino webinar. My name is Fabrice Bremule. I'm an IT consultant of ATIX, and today I'm going to present you with a general overview and the latest feature of Arduino. In the next 50 minutes, I will start to give a general overview about ourselves and about Arduino, how to use it and why to use it. And then in the following remaining time, I will give you a live demo to show you how Arduino works and how it's, in best case, used. At the beginning, I first of all want to tell you something about ourselves. So what do we do at ATIX? So our goal is to make life easier in data centers. So this means automation. We do that on many levels. For example, in supporting administration and deploying of container infrastructures, so as Docker, SUSE cars, or Kubernetes, as well as Red Hat OpenShift. We support the usage of configuration management tools like Puppet, Ansible, and SaltStack. And last but not least, of course, we also support administration and deployment of virtual machines, focusing on Arduino in this presentation, of course, now. So now the first question is, why do we need to automate it all? There are several points for that. The first point is speed. Suppose you have to deploy 20 hosts. So if you have to do it manually, this is a time-consuming job because if you do it one by one, this is something which can easily take several hours to possibly several days. By automizing, you can deploy a host, in case of Arduino, in best case, with just 3 clicks. I will demonstrate it to you afterwards. So if you deploy 20 hosts, this is something which can be done within an afternoon, in worst case. The second point is stability. So if you have to deploy 20 servers, which are supposed to be identical, you would like to have 20 servers in the end, which are identical. Not 50 identical servers, 3 servers with a slightly smaller hard disk and 2 with a bit more of RAM, because somewhere you made a slight mistake, a typo, and the configuration differs a bit. With automation, everything is scripted, and you also achieve reproducibility. So it means that you can increase your stability and you're reproducible by scripting everything and automizing. The next point is that you can orchestrate your services. So you can define all the jobs, all the services which are supposed to be run and deployed on your server. And then when the server comes online, it already is in configuration mode, so it can be used right away. And last but not least, it enables self-service. For example, if you have developers who are working on a development machine and something went wrong and they broke it and they need to redeploy it, a normal case would have open a ticket, and the machine is going to be redeployed, and until the ticket is processed, it can take several hours, maybe several days. And this takes a lot of time and also effort for all administrators. By automizing, you can allow the developer just to redeploy his own machine, and then everything is done within a few minutes. So what do we provide in ATIX? So we have several departments. First of all, we have a consulting department, which means if a customer is interested in Arduino, we set up an architecture workshop to see what infrastructure is around, what plugins and what else would be needed. And in the end, when everything has been summarized, we also install it for the customer. We have an engineering department, which basically develops Arduino. So we develop new versions. We test them, of course, before we release them. We develop new plugins and also plugins which have been asked by customers. As an enterprise solution, we also offer support. So this means in the basic support, there is a ticket system. So if there is a problem, the customer can open a ticket to our support. The support will have a look at it and solve the problem for the customer. We also have slightly more sophisticated subscription models, going up to that we even run the complete Arduino infrastructure for the customer if desired. Further, we offer trainings for customers who ordered Arduino. Then a consultant gives just a training for them and teaches the administrators how to use Arduino to get the best experience out of it. So, what is the idea of Arduino? The idea of Arduino is to map the life cycle of a server. We start with deploying the server, running configuration management, and in the end, also doing release management for the server. So the first step in the life of a server is the deployment. There are several ways to deploy a server. The first, most simple one is the so-called image-based deployment, which is the basic standard for cloud-based deployment. So we have a VM template, which is being cloned. Once the clone comes online, there are two ways you can connect to the clone. The first one would be via user data, so this is the cloud init-based approach. Then the server will run predefined commands and configure itself. The second one is configuration via finish template. So Orcharhino connects via SSH, and this way the commands are being executed and the host is being configured and gets everything run. The second way to deploy a machine would be a fresh deployment. So this can be done for virtual machines and for bare metal machines. There are two ways for that. The first one is if you have a DHCP server, which would be the network-based deployment. In this case, the network information is provided to the server via DHCP. In the other case, using static IP addresses, it's the so-called boot disk-based deployment. In this case, a boot disk ISO is uploaded to the server, and from there, the network information is being pulled. Once the server comes online, the provisioning templates are being pulled and being executed. In case of Red Hat, these are kickstart files. In case of Debian Ubuntu preseed, and in case of SUSE, this is an auto-yast file. Then after everything has run, this host comes online, is configured, and ready for usage. The third way to deploy a server is more for bare metal machines. The basic idea is the following. If you have several bare metal machines in the data center, you would like to switch on several servers and configure them to be deployed, and not switch one on, go to Orcharhino, configure one, and deploy. So the basic idea is that you use the discovery plugin, a discovery ISO, which is used for booting. You switch on all your different bare metal machines in the data center. They come online. You go back to your office. You have a look in Orcharhino, and there is a tab where you can see all the bare metal machines as so-called discovered hosts. From this point, you can just provision them like a normal virtual machine as before. You can even configure them that they automatically, depending on certain host parameters, provide themselves. So a certain parameter is given, and then automatically this kind of operating system with this layout is being deployed. So we support several hypervisors for normal virtual machines. We support, for example, VMware, Overt, Proxmox, KVM. We also support deployment in the cloud. In this case, it's Amazon Web Services, the Google Cloud Platform, and Microsoft Azure. The next point I would like to address is release management. So we provide release management for every typical Linux operating system. So these are all Red Hat-based systems like RHEL itself, CentOS, Oracle, and related operating systems, Debian Ubuntu, and SUSE. In order to provide release management, we are able to synchronize the repository locally to Orcharhino. So this means we just take an upstream URL, we create a repository in Orcharhino, and we synchronize, and all the packages are available. In addition to that, we supply security errata for all given operating systems. For those of you who are not familiar with the concept of an erratum is like it tells you if there's been a CVE, a bug fix, or enhancement. It tells you which packages are affected and to which version the package needs to be upgraded. So if you apply an erratum, it will just upgrade the packages which are affected to the version where the issue has been closed. In case of Debian Ubuntu, the concept of erratum didn't even exist. So we created a so-called errata parser, which was parsing the repositories, and we're able to provide information for Ubuntu and for Debian as well. Related to the repositories, we also create so-called content views. The basic idea of content views is to be reproducible. So suppose we have deployed a server today, which is up to date. Now in 1 week, 1 month, half a year from now, we need a server with exactly the same package state it has been today. This is what content views are for. So we can just assign certain repositories to a content view. And once we have done that, we can publish a new version. So once the new version is published, all the package states are frozen to the moment it has been published. So if I assign a server in half a year from now to a content view which has been published today, the server will obtain all the packages in this version which has been available today. The next point I would like to address is configuration. So there are several steps where a host is being configured. The first one is not directly configuration management, but it's still configuration when the templates are being run, every system, every packages and servers are being set up. The second point we have here is the actual configuration management directly. So we support 3 config management tools. These are Ansible, Puppet, and SaltStack. And they follow slightly different philosophies. Ansible follows more or less a fire and forget principle. So a configuration is being pushed by a server to all the servers which are being to be configured. Once it has been done, everything is fine, and normally it's not being repeated. Puppet is slightly different. Puppet is a server client system. So this means we have a Puppet master, which in general is the orcharhino, but it's not necessary to be a orcharhino. We can also attach external Puppet master and tell the master to push the reports and the facts to orcharhino. Then on all the servers, there is a Puppet agent running, which asks every half an hour to the master, what is the configuration? The configuration for the client is stored on the master. And if the configuration on the client is correct, it matches the one with master, Puppet is happy and just does nothing. If the configuration differs, it's being adjusted and the host is reconfigured so that it matches the configuration which has been given from the master. SaltStack is a bit of a hybrid between Ansible and Puppet in sense of you can run both principles on that. You can push configurations via SSH, like in Ansible, but you can also run a Salt master and running Salt minions on your clients and configure them this way. Using this config management tools, we can also configure the so-called OpenSCAP policies. So with OpenSCAP, we can define certain policies. For example, a service should be running, a package should not be available, or something similarly. And then the OpenSCAP run will check if the policies are fulfilled. If this is the case, then everything is fine. If not, the host will tell it's incompliant. And in this OpenSCAP report, we will see what needs to be done to make the host compliant again. The last point we have here are the so-called job templates. So if you have several scripts or something similar, which is to be run on several hosts, you can type them one by one to every host, which is quite time-consuming, or you can create a job template in orcharhino. You just write all the commands, and then you can apply them to several hosts, even in parallel as a bulk job. So for example, if you have one script which is to be run on 5 servers, you just check the 5 servers, you send the job template, and the 5 servers are being configured at once. So let's give me a summary about what orcharhino is now. So the basic source of orcharhino is an open source project called Foreman and Catello. While Foreman was the provisioning part, Catello is the part which allows us to synchronize repositories and content and assign it to servers. The config management tools we provide or we support in orcharhino are Ansible, SaltStack, and Puppet. As I said, we have an engineering and QA department which develops orcharhino, new versions, tests them, and also develops new plugins. An example for developed plugins by us would be the snapshot plugin for VMware and for Proxmox. So if you want to snapshot your host, it's not necessary to go to your compute resource and snapshot it there, but you can do it right away from orcharhino. Another example would be the SCC Manager plugin, so the SUSE Customer Center Manager plugin. In this way, we are able to synchronize subscriptions for your SUSE account if you provide the necessary credentials. In addition, we provide errata, as I said. So originally, errata were only available for enterprise operating systems. This would be RHEL and SLES. We also provide them for CentOS 7 and Debian Ubuntu, as I already mentioned. In order to deploy and support the enterprise, the operating systems, of course, we also provide the templates which are necessary to deploy the servers and the clients which are required to register the hosts to Orcharhino so that the content and the repositories can be provided. As I said, we offer support starting on ticket base, going to until to that we run the complete infrastructure. We offer consulting to advise customers how to set up Orcharhino, what plugins should be used. So there are many plugins available for Foreman. It is always good to have someone around who is familiar with plugins and can tell which ones are the most beneficial ones. From the consulting, we obtain training, which is also provided by consultants, and teach customers how to best use Orcharhino and get the best effort from that. So all of this defines the product of Orcharhino. In case you already want to see something now or how it works, here is a link to the documentation, https://docs.orcharhino.com. And on our YouTube channel, you can also see Orcharhino webinars from the last year. So at this point, I'm at the end of the first presentation. I will have a short look if there are any questions. Otherwise, I would continue with the live demonstration. So at the moment, there seems to be no question yet. So I would continue with the live demo. Okay, what you can see here is now the host page of our demo Orcharhino. You can see the many operating systems which we are supporting, starting with Alma Linux, CentOS, Debian, Oracle, Red Hat, SUSE, Rocky Linux, and Windows, and so on. So let me begin with just deploying a server. As I told you, if correctly configured, we can deploy a server with just 3 clicks. So we just click here on Create Host. When we get all the form here, we pick a host group. So for example, let's just deploy a CentOS 7. In the host group, all the parameters are predefined, which are required to deploy a host. I will explain to you in a few minutes what all can be configured. For now, I just want to show you how quick it's to deploy. We can set a host name or just use the one which is already suggested. So until now, we had 2 clicks. We click on Submit, which is the 3rd click, and the host is being built. So let's have an overview over the host. So you see here, we have a status. The status is okay, it's fine. We have now here build status, which tells us that the host is being built right in the moment. We have no build duration because the host has not been built yet. We see the domain, we see the IP address, we see a salt master, which could be defined as well as a salt environment, and many other facts. But maybe it's interesting to see how a host looks like when it's already ready. So let's have a look at a host which already has been built. So you can see that our host in this case is in error status. The question is why? So the status here defines a summary of all the different status down here. You can already see here from errata that this is the cause for the error status. In our case, this is on purpose because we keep our servers out of date to be able to demonstrate how to actually apply errata and close issues. So we see here our compliance run, so our open SCAP policy, our host is compliant, everything is fine, the host is built, configuration says no changes, so this applies to the configuration management runs. In case that everything is fine, but the last run did not change anything, it says no changes. If the run was successful but changed something, it would just say active. We see our remote execution status, so it tells us the last remote execution, which was run on the server, was successful. So we see the system purpose has been specified. The host is fully subscribed. This means that it is attached to orcharhino and is connected to the repositories. We see the traces that no process requires restarting, and the server does not need to be rebooted. So let's now have a look at the content of our server. For this, we go here to Content and have a look. Here in Details, we can see the environment our server lives in. So we see here that the server is connected to a content view and it's assigned to a lifecycle environment. The basic idea of a lifecycle environment is the following. In our case, we have 4 lifecycles. The library is the standard environment where everything starts. Many customers have a development, a testing, and a production environment. And in this, the idea is that we can provide different packaged versions for certain environments. So development would be the latest version, testing is slightly a bit older, and production, as it needs to be stable, would be the oldest package version. In our case, we see that this CentOS server is a test server, and it's assigned, therefore, to the environment testing. I will show you a bit later how all this is configured. In provisioning details, we see the data summary before. In subscriptions, we see actually what repository has been assigned to our server. So we see here, these are the subscriptions, and in repository sets, we see which repositories actually are active. So let me show you how easy it is to apply errata. So we have seen we have errata open. So if you click here on errata, we see now an overview, a list of the open issues. So let's, for example, apply now the erratum for open LDAP. We just click it, we click on apply selected, and then on apply. Now a remote execution is being triggered to the host. It connects via SSH, and the YAM action is going to upgrade the affected packages to a version where the issue no longer exists. So we see it's updating open LDAP. It's updating the package profile, so it's telling orcharhino that a new package version has been installed on the server, and it also updates the traces, telling orcharhino if any services need to be rebooted or restarted after the upgrade has run. So now if we go back, we will see once that the upload has been done. Let's wait a second until the package upload occurred. We will see that the erratum has been applied. And if we click on traces, we see that the following services need to be restarted because the OpenLDAP package has been updated. So in order to fix that as well, we just check all of them in this case. We click on restart selected, click on restart, and all the services are going to be restarted right now. So let's go back and have a look at our packages list. So if we look here, so we see the traces are gone, have been restarted, everything is fine. So packages. If we have a look here at installed, here we have a list of all the packages and the versions which are installed right now at the server. So for example, let's have a look if htop is installed. It's not. So let's fix that. For this, we can go to packages and to actions. Here on the left side, we have several options we can run. We can install a package, we can update a package, we can remove a package. In our case, now we want to just install htop. Click on perform. A remote execution is being triggered. We can have a look as well on the shell, what is happening. So we see the YAM action is going to be triggered. The moment the host seems to be busy. Come on. Okay, we'll have a look in a few minutes when it has run through. In the meanwhile, let's have a look where the content comes from. So for that, we go here to content and products. Okay, now we have seen, now it's being installed. Uploading the tracer profile. Everything is fine. We see here, now this has been a success. We go back here. We go to our package list, installed. We have a look for htop. And there it is. So now let's have a look where everything comes from. So in order to create the content which is connected to the servers, we go to our product page. Products are a summary, a clustering of repositories which are connected to each other. Let's have a look, for example, for the CentOS 7 product. We click here on CentOS 7, and we see in this case, we have three repositories in that, the OS repository, the extras, and the updates. Now, if we have a look in one of them, we see here what we have to provide in order to synchronize that. We have an upstream URL. We give the architecture if necessary, the YARN metadata, and this is pretty much it. Once it has been created, we can just go back to the page. And in order to synchronize, you would just check the one. We click on Sync Now, and now right away, it's going to be synchronized. Of course, you would like to be to have a most recent version of your package in addition to the ones you need. So for that, we can create so-called sync plans. So let's go back to our sync page. So we see this has been successful, was quite fast because there was new package available because the last sync was only 10 hours ago. So if we have a look at our products, we see that all our products have a sync plan assigned. So we see several products are assigned to sign at 3 o'clock, some at 2 o'clock, midnight, and spread all over the night. It's always a good idea to spread your sync plans over several hours to reduce the I/O, because if the I/O is too high, the performance during synchronizing might suffer a bit. So as I said, we provide content views as well, which are frozen package state, so that we can assign also older package versions to our servers. For that, we have a look on content views. So we wait a second until the page is loaded. So let's have a look at CentOS 7 content view. In this case, we can look at YAML content because CentOS is a YAML-based system. We have a look at repositories. And we see here, these are the three repositories which have been assigned to the CentOS 7 content view. If we look at versions, we see when the version has been published. So the version 7.0 was a version which has been published on June 3rd. So all the packages are the state of June 3rd. Version 8.0 is from August 11th. And version 10.0 is from October 1st. When we register a host to orcharhino, we have to provide two informations. The first one is a content view to which the server is going to be connected. And the second one is the lifecycle. All this is provided by the so-called activation key. The thing is, we only can assign one content view to our server. In case that we have several content views, because maybe we want to be able to update CentOS, Puppet, or different products independently of each other, we need to combine these content views to a so-called composite content view in order to be able to assign all of them to the server. So let's have a look at such a composite content view. So let's have a look at composite CentOS 7, as this is the one related to the one we have watched until now. So see again, we have several versions. We have a version 7.0, 8.0, 9.0, and we can see that they are in different lifecycle environments. Okay, this is a bit not an excellent example because all the environments are in the same version. Let's have a look at a different operating system where they are not clustered, like here. So let's have a look at CentOS 8. So we see here that in CentOS 8, production is assigned to version 11, or version 11 is assigned to production, and version 12 is assigned to library development and testing. So a CentOS 8 server, which has been registered to be a testing server, would be connected to the content view version 12 of composite CentOS 8. Production server would be connected to the same connect view, but it would only see the version 11.0. So let's say that we say version 12 has been tested, it's stable, and it can be assigned to production servers as well. To do so, we just go here to version 12, we click on promote, we assign production, and we click on promote version. Then production will be assigned to version 12, and the server will be connected to version 12 once the promotion is completely done. I won't do that here because otherwise we will have the same situation like in CentOS 7, which is not optimal for demonstrations. So we can also have a look at our lifecycle environments, which are right here. And here you can see the lifecycle path we can create. The most basic one, as I said, would be just development, testing, and production. But you also can just create content views which are ready at a certain point of time. For example, Q1 21, Q2 21, Q3 21, Q4 21. In the first case, we would just promote a content view version to assign it to a new server. In this case, we would just move the server to a different lifecycle environment to allow it to see new repositories. So let's go now through a few of the latest features we are providing. So we are trying always to be up to date, and therefore we are including always new operating systems or versions of operating systems. So let's have a look at the operating systems we are supporting at the moment. So in the last few months, operating system which has been deployed, published. So Alma Linux 8 has been published a few months ago, so we are fully supporting that. Another example of that would be Amazon Linux, as well as Debian 11, which has been released, I think it was end of July. Rocky Linux is such an example, as well as slash 15 SP3. One feature I've already shown you before were the traces, which were shown in our host before, telling if servers need to be restarted after some packages have been installed. Service tracers were available originally only for enterprise Linux systems. Now they are also available for SUSE, for Debian, and for Ubuntu. In addition, we improved our support for Windows deployments. So if you have a look here, you can see that we are supporting Windows 10, Windows 2016, and Windows 2019. And if you have a look here at our server list, we also have some Windows servers running right here. So we are able to deploy Windows both network-based as well as image-based. Another feature we are improving from version to version is the so-called application-centric deployment. I will only give a very brief summary because next month we will have an Orcharhino webinar, which is mainly focusing on these features. The basic idea of ACD is that originally everything was server-centric. So if you need to deploy an application which is running on several servers, let's say a Kubernetes cluster, then you need to provide several servers, you need to configure them, and this is normally connected with a bit of work. In this case, we can just create an Ansible playbook where all the tasks are summarized, which need to be applied to configure the servers. So we see here for the Kubernetes cluster, we can tell it where the playbook is situated. We can even do just pull the playbook from a Git server, which is one of the newer features we have right now. Then we have our app definitions. So we define what is a Kubernetes cluster. The Kubernetes cluster consists of a Kubernetes master. It's one, minimum one, maximum one. And we can assign a certain amount of Kubernetes workers. So the minimum count of the workers is 1. The maximum count is 4. So once we have defined that, we can create our actual instance. So now we have our demo Kubernetes running. So we can have a look how it's configured. So it's configured to be 1 master and 3 workers. So let's say we would like to deploy we want to deploy a Kubernetes cluster, or in this case, also redeploy. we can just click here on deploy. We can say delete all hosts because we want to redeploy, and now we click on submit. Now I will leave it alone for a few minutes or for a few seconds, because before it can start deploy, of course, it needs to delete the hosts, which is now happening right away. Another thing we are always working is, of course, as I said, development. So at the moment, we are running many tests. We are preparing the transition to part 3, which is going to happen around end of the year. And all the tests and preparations are running right now. And the last feature I would like, a new feature, okay, not the last, but another one I would like to show is, for example, if you want to configure a new operating system on your Orcharhino, which has not been provided before, there is a nice way we are providing since the latest version of Orcharhino, which is 5.10. So let's list our host. Now Orcharhino is now a bit busy, of course, because it's busy with deploying. This is a job template which is run on Orcharhino itself, so I will change the location because we assigned our infrastructure servers to a different location to be able to separate them from the rest. We click here on Orcharhino. We click on schedule remote job. We go to job category Orcharhino configuration. And here we can configure our operating systems. So let's just start to configure operating system which is not installed right away. So let's okay, I think we need to take an older one because the latest operating systems are all installed. So let's take it Ubuntu 16. We need to assign the location. I will explain right away what location organization is. In our case, our location would be demo, and the organization is ATIX. Now we click on submit, and we can see here that an Ansible playbook is going to be triggered, and it's going to configure everything. So we will leave it alone for a while. This is a task which is going to take a few minutes, so there is no point in waiting for it until it is finished. We can have a look at it in a few minutes if it is done or still running. So let's go back to our site where we deployed the Kubernetes cluster. So you can see here we have a report. It's telling us what the actual state is. So we can see here that report for the Kubernetes master. So we see the VM is being set up. The Puppet CA is being assigned. And right now, the host is in the process of being deployed. So we can have now a look at our host list as well. And we can see that all our hosts are in the build status. So we have to move back to our demo location. Wait a second until everything has been loaded. And we can see here that the hosts are being built. We can see that because right at the moment, there are no longer reports. They have been deleted when the host has been deleted, and they will reappear once the host comes online and the config management tools are running again. Another feature we included, this is documentation related. So if you look at administer and about, this is interesting for people who adjust their own templates, write their own templates. If you look here at template DSL, you can see other parameters which are being applied or which can be used. So you have here an overview, and in this way, you can see what is available and what you can use to configure your hosts and how to write your provisioning templates. So in the end, let's have just a look over all the different possibilities we can assign to our host. As I promised you, I wanted to show you how we can configure a host and what parameters are available. So this all is defined in the so-called host group, which I just mentioned before, but haven't shown you yet. So let's have a look at the host groups. So these are many host groups we created here. The most basic idea is that you can assign just a host group for a certain operating system. But of course, the idea is that a certain server role is being displayed by the host group, for example, an Apache server and so on. So you can define everything which is required right in here. So let's have a look at the CentOS 7 server, as this was the one we deployed. So first of all, of course, we have the name of the host group. We assign the lifecycle environment to which the server belongs to, the content view to which it is attached. We have the content source. The content source is, in this case, the orcharhino. This means here you put the server where the repositories are located to which the server should be connected. We have now our Puppet environment, which in this case is production. Deployer is the compute resource. So in our case, this is just our vCenter. The computer with a compute profile is something we like to refer as a t-shirt size. So this is a template for your virtual machine. It tells you how much disk space is there, how much RAM, how many computer cores, and where the disk space is located, and so on. So this is just a template. So basically, if you deploy a server and you don't change anything, it will be deployed as has been configured here. But when deploying a host, of course, you can override every single parameter and just use it as a starting point. Now here we have our Puppet configuration. So we have our Puppet proxy, which in this case is orcharhino. We have our salt master. Here we can assign the certain salt states, which are to be run on the servers. We can assign our Ansible roles, which are going to be run. Here we have our Puppet classes, which are assigned to our server. We define the network, the domain, the subnet, and so on, where the server is going to be deployed. Here we have the parameters for our operating system. In this case, we have just our architecture, which is an x86-64 operating system with CentOS 7. The media selection tells us what from what installation medium everything is going to be installed. We define the partition table, the PXE loader, and if we want to, we can also provide a root default password for all the servers. Everything we have here can be overwritten when actually deploying the server. In addition, we can set several parameters which are interesting and are being used in the provisioning templates. In this case, for example, we have Puppet class parameters which are being set. So for the Crony class, we can just define the servers which are going to be used. Here we have the parameters which are going to be used for the format SCAP client. In addition, we have here host group parameters which tells the server in the template, in the provisioning template, what to do. For example, we tell that the firewall should be disabled, upstream EPEL should not be enabled. We attach the OS repository, and we tell the server, in our case, it's reasonable. In customer's case, might not be reasonable. In this case, we should change it to true. So this parameter tells if a server should be upgraded to the latest version, which is available in the content views, or not. Now the last parameters we have here is the location. So location is what you can see here. We have here in the top, on the left side, the organization, which is ATIX in our case, and the location, which is demo. The idea behind that is the following. So suppose you have several departments in your company, and you would like to separate them. So department 1 should not be able to see or to mess with servers of department 2. So you can assign a server to a certain department, and via the user roles, you can limit the access to the servers this way. A second way to split servers would be a location. The location is not as strict as the organization. The idea behind that would be, for example, if you have different data centers, you can assign servers from data center 1 to location 1 and from data center 2 to location 2. But these are just examples. You can assign servers to different locations and organizations as you like. So here we have our organization. And the last point in our host group is the activation key. So the activation key tells you to what content your server is going to be connected. So as we are here in the activation keys, let's continue with the activation keys. So the activation keys you can find in content. Now here to activation keys. So this was the key CentOS 7 test. So let's have a look at this one. You can see here, CentOS 7 test is going to connect your server to the content view composite CentOS 7 and to the lifecycle testing. This is the first point. So this defines what is the pool where a server is allowed to take repositories from, but not yet does know which one are going to be taken. This is what subscriptions are for. In subscriptions now, we assign the products to which the server is connected. So in this case, all CentOS servers will obtain the product CentOS 7, the client for CentOS, EPEL, Puppet, and SoulStack. Looking at the repository sets, we now can see here, as we saw in the server before, the repositories which actually are enabled. So we see the CentOS 7 client. The CentOS 8 client has been disabled because it's CentOS 7 system and does not need to be connected to CentOS 8 client. So you see, this is the way how we assign the content. Now let's have a look if our host, which we deployed at the beginning of a live demo, is already online. So this was the webinar CentOS 7. So we see actually there is a report. So let's have a look at the report. So you can see here configuration, that's what I mentioned before. Configuration is active, so this means the last configuration run was successful and actually changed something. So let's have a look at our reports. So we can see Puppet has been running for 20 minutes now since it came online. By standard, we have a certain timeout or a countdown which defines when Ansible roles are being run. So we are using Ansible to configure our host as well, but we have to make sure that the host is already online and functional and connectable via SSH when Ansible tries to run. So we can define in our settings how much time orcharhino is to wait, is allowed to wait until to run the Ansible roles, and then when the time is done, all the roles are being run. So we see here, we get our Ansible report as well. We can have a look at the report, and we can see that in this case, the message of the day has been written on our server. So until now, we didn't have a SoulStack run, which is only going to be to run once an hour. Let's have a look at a different server where SoulStack already has run, so you can see the third kind of report as well. So let's have a look at our backup system. We go here to reports, and you can see here that once an hour, SoulStack is running as well. And if we have a look at the first report where the change actually happened, we see that in this case, also the message of the day has been run. So technically, it doesn't make too much sense to manage the message of the day, both with SoulStack and with Ansible. But in our case, to demonstrate, it's a perfect way to show how it actually works and how we can override each other. So let's go back to our host page. So let's have a final look, a general overview we have here. So we can have a look at our dashboard as well. So you can define your own views. You can see the host collection, the subscription status. Content views have been published, the latest errata, which became available, and much more. Here we have a summary of all the facts of all the servers we have on orcharhino. On jobs, we can have a look at that. We have a list of all jobs which have been triggered. So we see here several Ansible roles which have been triggered when deploying a server. We see the htop we installed before. We see the errata we applied. We can have a look here as well as the tasks. So here we see all the tasks which are running in orcharhino. At the moment, everything is fine. Nothing is running because everything has run through. So if we're synchronizing repository and so on, this would be available here. We can also see if something went wrong. So as I said, here we have our content. This is related to the products we had before. Here we have our subscriptions. So we have a subscription for all our different operating systems. Now we have two slightly different ways to assign production. So I showed you the version for CentOS 7, which is an open operating system. In case of Red Hat and SLAS, it's not that straightforward because you need, of course, a subscription for that. So in order to synchronize Red Hat repositories, you need to download a so-called Red Hat manifest. Then you go here, you go to Manage Manifest, you can upload it, and once you've done that, you can go here to Red Hat repositories, and on the left side, you will see all the repositories which are available for you. On the right side, you see the repositories which you actually have enabled. Similar, but technically slightly different is SUSE. So we can have a look here at our SUSE subscriptions. So this is the SEC Manager plugin I mentioned in presentation before. Here we can assign just an account. We define a name, we define a login, we provide a password. Once we have done that, we can synchronize that. Once that's been synchronized, we see the products which are available for us. Now we can just click on select products, and we will see a large tree with all the subscriptions which are available for us. It's going to take a bit because it's a quite large list. Come on. Okay, we'll get back later to it. No problem. So here we define the sync plans I mentioned before. We can define as well certificates and GPG keys for all our repositories which are necessary. We see the architectures, the operating systems. As I mentioned before, we have installation media. So here we define the path to the installation media, which are provided for all our hosts. So now, in the meanwhile, the list of SUSE repositories have been loaded. So we see here we have many opportunities. So suppose we want to just enable a certain additional subscription. Let's take a more recent one. So let's take, for example, the high availability extension. We click on that. Now it's being checked. We click just on submit. And once we do that, the product will be created as well as the connected repositories. So let's have a look at the products right now. It should be now in the process of being created. Here it is. So we see here the repositories have been created. 4 repos are there. Everything is fine. Here we see the page where you can configure hosts. You can define the host groups. Here we can configure actually the Puppet classes, which are available in orcharhino, the Ansible roles, the salt stack states. Under infrastructure, we can configure the smart proxy, so it's orcharhino, and the compute resources, which would be the vCenter, Proxmox, or any hypervisor you're using. The compute profiles define the t-shirt size I mentioned before. The network is defined right here. Under administer, we configure our location. We can configure an LDAP or an AD access. We can assign roles for our users so that we only get limited access. And we can define all the different settings. And last but not least, we can have a look at about. And when we see the backend status, we see the plugins which are installed on your orcharhino. We see the support. So the link to the documentation, the link to the ATIX service portal, the template DSL, as I mentioned before, and we can see how many managed hosts are connected to orcharhino at the moment. So basically, let's have a final look at the host we deployed, if there's still something which I missed to show you. So let's have a look at the webinar backup. But it looks quite fine. I already showed you how to run this kind of remote job. The last thing then what I would like to show you is that once the server is no longer needed, we saw the whole life cycle of the server. I can show you the end of the life cycle. You can just delete the host with one click. Click on OK. Wait a second until it's been deleted on the vSphere. And the host is gone. So at this point, I'm at the end of the live demo. Let's have a look if there are some questions in the chat. So there seem to be no questions yet. So in case you have any questions, you can just write to ATIX and ask them later. So far, then we are at the end. Thank you very much for your participation and have a nice day. Bye.